Hello everyone, this is Deepak Joshi, and today we are going to solve another problem statement from Geeks for Geeks, that is bottom view of binary tree. In this particular problem, what we need to do is we need to find out the bottom view of a binary tree. Like, what is a bottom view, first of all? So bottom view is nothing but the nodes that will be visible when a user or when anybody will watch or try to see the binary tree from its bottom. For example, for example here with this particular example, if I try to see this binary tree from the bottom, then what I'll be able to see is 5, 10, because 8 will be covered by 10, then 3, or 4, like 4 will be there, they are considering 4, and then 22. In place of 22 I'll be able to see 14 and then 25. And for this is a very simple example of a binary tree, like 3 1 2 is like when I'll try to look at this binary tree from the bottom, I will be able to see only 3 1 and 2. Like, you can assume this as a linear y-axis graph. That will help you more to analyze, like, how we can try to resolve that this particular problem as well. So if I try to place 3 1 and 2, which is something like this, into a straight line, then what I can do is I can consider 1 as the frame of reference or the origin, that is 0, and 3 is on its -1 side. We are not considering vertical approaches here, we are considering only horizontal ones. So 1 is at 0, 3 is at -1, and 2 is at +1. Okay, and if this graph grows, we will subsequently updating the y-axis value instead of like keeping the track of all. For example, here 20 is left, that is -1, -1 is 8 है ना, and थोड़ा आगे जाते जाते we got -1 as 10, so we will update that -1 to 10. That makes one thing clear, that what we can do is we can have a map that will, or a key value pair, what that will be taking care of all our horizontal um, horizontal key value pair that we are trying to have. The key will be the y-axis trace, and the value will be the nodes value, or you can store the node as well. I will be storing the nodes data because that will be further easy. I don't want to. Okay, so nodes data. Now this is the first thing that we need to consider. But how we will be able to trace this whole graph? So tracing it completely can be done using BFS, breadth first search. Why not DFS, and why BFS? Because I want to trace the whole level in one go, so that I don't want to come above and then start from again. Because considering one level, there will be finite number of what there will be finite number of bottom view nodes. And also, one important thing, the reason why I'm considering grid first search here is, let's say I considered depth first search. I'll go from 28 and 5, and let's say I'm on 10, or on 3, or on 14. I have not like, let's say I'm on 14. Okay, I'm on this node, I have come to this path, like 28 3 14, but at that time I have not considered 22. That is the wrong thing. And well, I will consider 22, and at that place I'll find, okay, -1 पर तो 14 lie करता है, but and I'll update +1 पे, and I'll update it to +1 पे 20 lie करता है. That will make our calculations wrong. But if I have considered breadth first search, then I will be very sure that I have considered the first level nodes, second level nodes, third level nodes. Now, or the fourth level, my +1 will be on 22, and I'll update it to 14. That is the surety that breadth first search will be giving us to me. Okay, so now we are clear that what data structure we are planning to use, and what approach we will have here. So let's start implementing that. So how we implement breadth first search is, we implement breadth first search using um, using the queue data structure. Okay, but like, for that queue, what we need to consider here is, like, in that queue we will be storing the node, but we need to store one more thing, the position of it, the y-axis position. For example, we are considering root node as the origin. That means anything which is on the left side of the root node will be -1 of the root node position index, and anything on the right side of the root node will be +1 in the index. Okay, and subsequently in the recursion, or in the while loop, we'll see we will be adding -1 to the left ones and +1 to the right ones. Okay, that makes sense, if that makes sense. So let's implement the queue. The queue will be up here, that will be having a node and an integer. Okay, simple, as simple as that. Now we do need a map that will be int comma int. Okay, let's name it as map. What we are going to store in this map is the scale and the node value. Okay, that is that will be there, and that makes sense. Now in this queue we will first store the initial value, that is root, and the index of the root will be 0. Now we will iterate over this using the traditional way of queue.empty. If it is not empty, please start iterating. I'll get the queue.front. Okay, that is what we can do over here. Now we have got the queue.front. We need to extract the node of that particular front and the scale of it. Okay, so how we will do it is node star front node, that will be equal to it dot first, because we have already stored it, it dot first, and int index, that will be it dot second. That makes sense. Now we can pop it up. We could have pop it up here as well. That makes completely sense. Now we have the node and we have the index. We just need to map it up. Okay, so the index, or the better name for this will be line index or y-axis index, like variable names can be discussed. Line index, and we will map it with the front nodes data. You can map it up with front node as well. You just have to update this relation over here, but I'm mapping it with the nodes data. Now we will make sure if the left exists of this particular front node. If left exists, that means it will be not equal to null. In that case, what we need to do is we need to push things to the queue, and we will push, not this, front nodes left, and we will push the index, and the index for the left one will be index -1, or not the index, uh line index. Okay, that makes completely sense. If we'll check the right exists for this one. Okay, if the right exists, then what we will do is we will, okay, we will push the right into it, and the line index +1. Simple. That makes completely sense. So over here, let me just go through it, and then we will try to figure out like what is happening here. So here we have created a queue that will store what, the node and the index, that is y-axis index that we are considering, because we are considering the horizontal, considering whole this graph on a horizontal line. Okay, now there is a map that will be storing the scale and the node value. Okay, we have considered the root as the origin, that is root that will be at index 0, or the origin frame of reference. Okay, now we are starting the DFS, sorry, BFS, that is breadth first search. We are getting the queue dot front, the first element of the queue. We are popping that out because we do not need it further any further. Now we are getting the front node from that iterator, that is it dot first, and getting the line index, mapping it up line index with the front node data. If the front node exists, simply update the queue. If the front nodes right exist, update the queue. If the front nodes left exist, update the queue. That's it. Now, what will be there in our map index? It has been updated many a times. For example, let's say for 22, it will be it will be uh, the root and the index. So for 22, the index will be +1, and the root data will be 22 for this line I'm talking about. So map of +2 will be equal to 22. But when it come to 14, the map of +2 will become 14. That means all the below present nodes will be only there in the map. All right, that was the thing, that's why we considered y-axis over here along with a map. So what we just need to get all the bottom view nodes, is we need to return a vector, so we can create a vector of int that is answer, and we just need to iterate over uh, this map. We can do this by doing this and mapping it up. I'm just answer dot pushback, and that will be it dot second, because we have stored the value of nodes value in it dot second over here. Okay, not over here. Here is it dot second, and we just return the answer. This is what uh, the whole thing is, that it will be able to cater the issues, and it was able to. Let's submit it and see whether it works or not. Yeah, it seems to be working fine. If there is any issue that you face, or if there is any problem that you want me to solve, please feel free to comment it out. We'll see whether I'll be able to help you out or not. See you in some other video. Bye bye. Take care.